We now go through some problems on section 1.7. Okay, the first question is about, we consider three functions f. Each one of them is continuous at x equals 0. That is, limit x approaching 0 of fx is f at 0. In order to show by the epsilon delta definition that this is true, one has to give definition of delta in terms of epsilon. That is, absolute value x minus 0, that is a, less than delta implies absolute value fx minus f0 is less than epsilon. Let's match these choices. All right. So let's remind ourselves what is the definition, precise definition of limit. Suppose f is a function defined near a number a, except possibly at a. We say that limit x approaching a of fx is L if given any epsilon greater than 0, there is a delta greater than 0 such that whenever or if 0 is less than absolute value x minus a less than delta, then absolute value fx minus L is less than epsilon. Now, you are given three functions. We want to show that limit x approaching 0 fx is f0. Here, a is 0. Now, suppose you are given any arbitrary epsilon greater than 0. That's the hypothesis. Given any epsilon greater than 0. We want to find a delta. There is a delta. So we want to find that delta. The first function is fx equals x. In other words, f at 0 is 0. That is our L. All right, that's our L. Consider the inequality absolute value fx minus L less than epsilon. So we always start from here. Use this information to find this delta. Okay. What is our story? Fx is x, L is 0. So this is nothing but absolute value x minus 0 less than epsilon. Wait a minute. This is precisely here. X minus 0 is what you're looking for. So, in other words, my delta is epsilon in this case. So, delta is epsilon. So, fx equals x corresponds to delta equals epsilon. Next function is fx equals x squared. F at 0 is 0, which is your L. So we want to consider the inequality fx minus L, absolute value of x minus L less than epsilon. Fx is x squared. Absolute value x squared minus 0 less than epsilon. That is absolute value x squared less than epsilon. Square can be taken out of the absolute value because you see, once you square it, it's positive. Once you take absolute value, it's positive, non-negative rather. So they are interchangeable here. Now, what is the advantage of that? I can take square root. Okay. Taking square root maintains inequality. Okay. Because square root is an increasing function, maintains inequality. But the left-hand side is precisely absolute value x minus 0. Right-hand side is square root of epsilon. So in this case, the delta is square root of epsilon. So for the second one, delta is square root of epsilon. So this is 3. Well, obviously, the first one, the 1 will go here, but let's argue. Fx is square root x. Notice square root x for real valued functions, you want x to be greater or equal 0. F at 0 is simply 0, that is L. Consider this. Absolute value fx minus L less than epsilon. Fx is square root x. Absolute value square root x minus 0 less than epsilon. In other words, absolute value square root x is less than epsilon. Square both sides, you get absolute value x less than x squared. That is, absolute value x minus 0 is less than epsilon squared. So this quantity is your delta. So delta is epsilon squared. So that's 1 here. And check answers. Everything is good. Next. You're given a particular graph. Fx is 1 over x. That's your function. Find the largest number delta such that absolute value, my function minus 0.5, so that's your limit, is less than 0.2. So you see 0.2 is the distance between fx and your limit. So I'll add 0.2, that's what is giving you 0.7. Subtract 0.2 and that's what is giving you 0.3. So this is 0.2 distance from 0.5, right? So that's your interval. Corresponding to that interval, let's look at the interval around 2. So you see all of this is happening around 2, x minus 2. So you notice you have a certain distance here and you have a certain other distance. Where did you get these numbers from? Well, those are the numbers which correspond to your lower and upper limit here for f. So delta should be small enough and symmetric. If I take this particular distance, well, that's too big because its symmetric image would be farther beyond my allowed range, you see. So I need the smaller one so that its symmetric distance also is within my interval. So that distance is delta, okay? So 2 minus 10 over 7 is the delta that you need. We need smaller distance. 2 minus 10 over 7 is 14 over 7 minus 10. You see 2 is 14 by 7. In all, delta is 4 over 7 and that is this distance. So this is 4 by 7. Next. How large must x be so that e to the negative x by 10 is less than 0.1? Okay. E to negative x by 10 is less than 0.1. What does that mean? This is negative exponent. So it's same as saying 1 by e to the positive x by 10 is less than. 0.1 is nothing but 1 by 10. Well, when you flip fractions, inequality changes. Another way of thinking about it, cross multiply. Remember, when you cross multiply, the numerator side stays on its side. In other words, this times this goes here, this times this goes here. So the numerator side gets, because I'm making a fuss about this because inequality has to be respected. All right, 10 is less than e to the power x by 10. What does that mean? E to the power x by 10 is greater than 10. You see, I flipped it, so the inequality changed. My goal is to understand x. So take natural log of both sides. Okay, natural log is an increasing function, so inequality maintains. Natural log of the left is greater than natural log of the right. Natural log of e to anything, well, they go away. You're left with x by 10 greater than natural log of 10. Multiply both sides by 10. 10 is positive, inequality maintains. X is greater than 10, natural log 10. How large must x be? That is, x has to be greater than what? 10 natural log 10. Next. All right. Recall that limit x approaching c of fx is L. Means for all epsilon greater than 0, there is a delta greater than 0 such that for all x satisfying this condition, we have fx minus L absolute value less than epsilon. What if the limit does not equal? So if it is not equal, what does that mean? This entire statement must be false. Okay? If limit is not equal to L, this statement has to be false. In other words, we want to negate the given statement for all epsilon. Negation for all, negation becomes for some. For some epsilon greater than 0, there is, negation of that is for all delta greater than 0, such that for all x, there is some x. Negation of for all is there is some, such that this condition is satisfied, but that condition is not satisfied. So, but this condition, it should not be greater than, it should be greater equal, but I don't have that as an option, so I've written it this way. It should be greater equal here. So notice I want to write this sentence. So for some epsilon, there is some epsilon. So the first entry is 7. Epsilon greater than 0. What's the next? For all delta, 6. Delta greater than 0, 2. There is some x. There is some x such that, so that's an 8, such that this condition is satisfied, 3, but that condition is not, that conclusion is not satisfied. So but is 5. You have absolute value to be greater than epsilon 4. All right, next problem.